tutorial is about electric field lines. Now, field line gives the geometrical description of electric field. To understand the concept of electric field, let us consider a single point charge Q situated at the origin. Now, electric field due to this charge Q would be A is equals to 1 upon 4 pi epsilon naught Q upon R square R cap. Now we can now draw a vector pointing along the directions of electric field with length of these vectors proportional to the field at each point. So let us draw these vectors along each possible direction. Now since electric field falls off like 1 upon R square, this vector goes shorter and shorter as we goes away from the origin, pointing in a radially outward direction. Now if we connect up these vectors to form a line, we get a nicer way to represent this field and thereby forming the field lines. That is, what we have to do is connect these vectors to form field lines. Now the magnitude of field is indicated by density of these field lines, and the magnitude is stronger near the center where the field lines are closer together, and it becomes weak as we move outwards as field lines are relatively apart at outer points. So we can now conclude that electric field lines are imaginary line that are drawn in such a way that its direction at any point is same as the direction of field at that point. Now electric field of a single negative charge would point in a radial inward direction terminating at the charge. Now in general, for a configuration of charges, an electric field line is a curve drawn in such a way that tangent to it at any point is in the direction of the net field at that point. So we have seen how to draw field lines for a single positive and a negative charge. We can also draw field lines around a system of two positive charges, and this figure shows the electric field lines due to two positive charges. And from this figure we can see that field lines along a system of two positive charges describe the mutual repulsion between these two charges. And this figure shows the electric field lines due to a positive and a negative charge. And from this we can clearly see that electric field lines around the system of a negative and a positive charge describes the mutual interaction between these two charges. Now some important general properties of field lines are: field lines start from positive charge and end on a negative charge. Now two field lines never cross each other. Because if they do so, then at the point of interaction there will be two directions of electric fields, which is impossible. Now, electric field lines never pass through a conductor, and this shows that electric fields inside a conductor is always zero, and electric field lines are always continuous curve in a charge-free region.